So welcome back to Level 3 Mechanics, Level 3 NCEA Physicists. Last lesson we looked at gravity as a general concept, and today we're going to go into a little bit more depth by looking at the concept of gravitational fields. So the first thing is, well, what's a force field? Okay, so basically a force field is a vector field, so it has a magnitude and a direction, that describes how a force, a particular force, in this particular case gravity, would act on a particular object at various positions in that field. Okay, so for a gravitational field, the symbol is little g, and the units are going to be newtons per kilogram. Okay, so what force is acting on a particular mass. So indeed, gravity is a field. Okay, so gravity is an attractive field as well. It goes towards the mass. Okay, so that's an important distinction from other types of fields. So if you're stuck out in space, you're going to be attracted to the massive mass of the Earth in an attractive way. So you may have seen this, the idea of gravity as a field. So essentially the force of gravity is weaker further out and stronger as you go in. And it's the reason why there is an escape velocity and it's quite high, is because you're experiencing quite a strong force of gravity which pulls you towards the center of the Earth, whereas further out, once that escape velocity has been reached, there is very little attractive force, say, on the edge of the universe, so it weakens due to that r squared value in the equation. Okay, so in terms of gravity as a field, basically a gravitational field distorts the space around it, so you could consider it as maybe space as being a rubber sheet, and the bigger masses curve that rubber sheet more than the smaller masses. Okay, so it basically means that a mass will essentially know how to respond to adjacent masses next to it because it is in this gravitational field. So in terms of gravity acting as a field, how do we actually visually represent this? Okay, so you'll notice the different force vectors, and you'll see that the length of the force vectors increases the closer you get to the surface of the Earth. Okay, so a stronger force is being experienced by objects closer to the Earth than it does further out. That's why the arrows are smaller. So the direction is consistent. It's towards the center of the mass, but the size or magnitude of that gravitational force is lessened the further out you are from the mass. The gravitational force is weaker. Okay, so the length provides the strength or magnitude of that force being experienced by that object at that particular point. And the closer they are together as well also provides an example of strength. So the closer these field lines are together, the stronger the experience is for that object at that particular distance to the other mass. Okay, so remember little g, okay? So little g, of course, is 9.81 meters per second on Earth, or at least on the surface of the Earth. And g, what you would have done last year would have been the acceleration due to gravity. But it's not quite the whole story when it comes to physics, because that little g is also the gravitational field strength. Okay, so force equals mass times, or the weight force at least, is going to be mass times the acceleration due to gravity. But also the gravitational field strength will be the force being exerted in terms of gravity on a particular object divided by its mass. Okay, so it's going to be dependent, directly dependent on the force being exerted but also inversely proportional to the mass. Okay, so what does this actually kind of look like? Well, G can also be represented as the gravitational constant times the mass of that heavy object, or that massive object, say the Earth, divided by the radius from that center. Okay, so the orbiting altitude, the orbiting satellite here around the planet, so the radius will be the radius of the Earth plus the orbiting altitude, and the mass will be the mass of the more massive object, in this case the Earth, divided by that radius squared multiplied by this gravitational constant. Okay, so you can see the further you go out, then the acceleration due to gravity is less and less by that r squared value. And that is pretty much what we'll be looking at in today's lesson.